In this video, we're going to take a look at law of cosines. Now, up until this point, we've talked about the law of sines, right? And if you remember which types of triangles law of sines can solve for, it can solve for your angle, side, angle triangles. It can solve for your angle, angle, side triangles. And remember, we spent a decent amount of time talking about side, side, angle. This is the one that gives us fits, though. Sometimes there's zero solution, sometimes there's one solution, sometimes there's two different triangles. All right, so, but pretty reliably, or always reliably, we can solve for angle, side angle, and angle, angle, side. The side, side angle, again, it's kind of a bit of a unique case. So that leaves law of cosines. So law of cosines is going to help us solve for sides and angles of triangles that we are given side, side, side for, and triangles that we are given side, angle, side for. Now, let me just say this on the front end. The law of cosines is more complicated. There's a few more things going on. It's easier to mess up the formula. If you have the choice in your life, say you have a triangle with two sides and two angles, and you could do the law of cosines or you could do the law of sines, 10 times out of 10, I would be doing law of sines. Okay, law of cosines is useful, and when we need to use it, we're gonna use it, but I would not use law of cosines any more times than you have to. So how's that for ominous start here? All right, so law of cosines, what exactly is this terrible thing? Well, let me show you here. Law of cosines is very similar to Pythagorean theorem. We're not going to prove where it comes from, though we could if we wanted to, using some trig and some Pythagorean theorem. But you get, if we're taking a look at this particular formula, let's just look at the first one. A squared equals b squared plus c squared. That's usually Pythagorean theorem. Well, it is Pythagorean theorem, and we use it for right triangles, but when we're not dealing with right triangles, we have to make an adjustment. Okay, and that adjustment is minus 2bc cosine A. Now, let me kind of show you what's happening here for kind of an easy way to remember it. Okay, you could think about this by thinking Pythagorean theorem, a squared, b squared, c squared, and then minus 2. I don't have a way to remember that, but then you can almost go backwards here, c, b cosine A. And so notice that our ends are the same, and you could almost think of this like climbing up a mountain, climbing down a mountain, or a sandwich where we're putting, equal things on both ends and then slapping it together, You've got bread, then turkey, then cheese, and ham, or however you set up your sandwiches, okay, if you do it that way, okay? So, all that to say, that's an easy way to remember it. I'm not going to expect you to memorize these formulas, but if you can remember it, it might save you a little bit of time. Now, notice, we have 3 different formulas. All of them are the same thing. It's just if I'm dealing with different sides. Like, for example, let's just come up with a side angle side here. So let's say this is 10. Let's say this is 11. Let's say this is, 120 degrees. Okay? In this case, I've got angle B, and I've got A and C. So angle B, A, and C. That tells me that I need to solve for side B. That means I'm using this middle one. Okay, but again, we could rearrange all these letters. It's not a big deal. Really, the key thing here is whatever is by itself, whatever side is by itself, is going to be the cosine angle. The b squared plus c squared are going to be the same letters that end up in your 2bc, or your a squared plus c squared is 2ac. Okay, and it's always a minus sign, always times 2. So let's use this, and let's go ahead and solve for some sides and angles. So let's start with a side angle side. Example here. I've got this side, I've got this angle, I've got this side. Okay. Now what I'm going to do is I'm just going to call my side angle pair that I'm looking for. I've got an angle and I'm looking for the side here. I'm just going to call those A's, and then I'll call this B and I'll call that C. But again, you could call them whichever order you want. And let's go ahead and write out our formula here. So I know side squared A squared is equal to B squared plus C squared is not equal to, minus 2bc times cosine of A. Okay, so that's the formula I'm going to use here. So let's go ahead and plug some numbers in here. So the A side here is x, so I've got x squared is equal to my b squared, so 7 squared, plus 4 squared, minus 2 times 7 times 4 times cosine of 52. Okay. Now, here's what I would recommend. Okay, that's kind of, looks like 27 is 2 times 7 times 4 there. Okay, here's what I would recommend. If we're plugging this into our calculator, I would just recommend plugging the whole thing in. Okay, this is where people go wrong. Okay, I'll show you where they go wrong, and then we'll kind of talk about how to plug this in. This is what they do. They say, okay, that's 49, that's 16, that's 2 times 7 times 4, 28 times 2 is 56, minus 56, cosine 52. Okay, and then they add this, they get 65 minus 56, cosine of 52. All right, so we good so far. Feel like we've got this thing under control. And then this is where they make the mistake. They say, oh, 56, 65 minus 56, that's equal to 9 cosine 52. Wrong. Do not do that. Okay, can you tell me what's wrong about this? Can you figure out why can't I just subtract these numbers? Well, if you're thinking about this correctly, look, this is not 56. This is 56 cosine 52. It's 56 of these cosine 52s. Okay, this is just a regular 65. So we cannot subtract those. What we need to do is you need to multiply these in your calculator first and then subtract them. But the thing is, you're going to need your calculator no matter what. So instead of making those errors, what I would just say is let's just get ourselves to this point right here. Let's just plug all that in the calculator, and then we can take the square root to solve for x. So let's do that. 7 squared plus 4 squared minus 2 times 7 times 4. And once again, remember, you do need your calculator in degree mode, or it will not give you happy answers. All right? So we plug that in. We get x squared is equal to 30.522, or actually 23. Now, until I have my final answer, what I want to do is I want to go out to at least 3 decimal places, okay? Especially if I'm solving for multiple things. So until I'm getting a final answer, just keep that decimal place a little bit longer, or use exact values. You can do second answer or copy and paste, any of those. The reason you want to do that is it keeps your answer as accurate as possible, and it helps keep you from doing rounding errors. Like say I round that to 31 and then I take the square root and I round it again, you can really get kind of far off your answer doing that. All right, let's go ahead and take the square root of both sides here. So second square root of my answer, and I get x is equal to 5.525. All right, but again, I'm going to round my final answer to the nearest tenth, so I get 5.5 as an answer. All right, and if I'm thinking about this, it should be less than 7, right? And triangle inequalities also tells me it has to be bigger than 3, because the two small sides have to add up to be bigger than the biggest side. So it has to be between 3 and 7 somewhere. 5.5, that checks out as a reasonable answer. So that's if you're solving for a side. Say you have side angle side, you're solving for a side. That's not too bad. You plug it in, it spits out an answer, take the square root, thumbs up, we're ready to roll. All right, this is where things get a little more complicated. Let's say I want to solve for an angle. Okay, let's say I want to solve for angle C here. Okay, now in this case we'll use the C formula here. So we're going to use C squared is equal to A squared plus B squared. So that's just Pythagorean, minus 2 times A times B times cosine of capital C. All right, so let's go ahead and plug in our values. And again, notice that's A, that's B, and that's C, because those are opposite our letters. So I get 12 squared is equal to 15 squared plus 13 squared minus 2 times 15 times 13 times cosine, hang on, sorry, ignore that piece right there, times cosine of C. All right, so let's do a little solving. So again, what I'm going to do is I'm just going to do the squared. So that's 144. 15 squared. 15 squared is 225. 13 squared is 120 or 169. 2 times 15 times 13. We get 390. cosine of C. All right. So let's take a look. Now, let's go ahead and combine these two, right? So 225 plus 169. Now, in this case, we do need to kind of take this step by step. Sorry, there we go. So I got 144 is equal to 394 minus 390 cosine of C. Okay, what we need to do is we need to get the cosine C by itself and then take cosine inverse. So once again, we cannot do 394 minus 390. Okay, you're going to get the wrong answer. It's not going to make any sense. Okay, what we need to do is we need to subtract 394 from both sides. So I get 144 minus 394. I get negative 250 is equal to negative 390 cosine C. Okay, so I'm going to divide. Now I can go ahead and deal with that negative 390, and I'm going to deal with it by dividing by negative 390. So I get negative 250 divided by negative 390. And I'm going to get this nasty decimal, okay? But it's important that we get a lot of decimal places. So you get 0.64102, okay? I'll take it out 4 decimal places is equal to cosine C. All right, we're running out of space here. Last step. Okay, so whenever I'm trying to solve for an angle, right, I need to take the inverse cosine or the inverse sine. Same thing here. So I'm going to take cosine inverse of 0.6410, or if you can just get the exact value, that's great too. So cosine inverse, we end up with 50.13, okay, or we'll just go 50.1 degrees. All right, well, that was a lot of work. Yes, it was a lot of work, okay? Law of cosines just takes time. It's unfortunate. It's the way it works. So if there was an easier way to solve for these things, I would tell you, and we would be able to solve for them that way. Unfortunately, there's not. This is what we have, okay? Now, I do want to point out one other thing here. Let's do this. Okay, I'm going to clear the ink here. I'm going to plug this 50.1 back in here. Now, some of these are going to ask you to solve for multiple angles or multiple sides and angles. Now, this is what I would do. I would not use law of cosines more than once. Okay? I would use it as few times as possible. So I've used law of cosines. I've got an angle. Okay. Now, at this point, what I'm going to do is I'm just going to solve for my next smallest side. Okay. If I solve for my next smallest side, I should be fine. I shouldn't run into any angle side sort of troubles. But let's go ahead and take a look here. So here's how I would set up. Say I was solving for angle B. Or I'm sorry, solve for my next smallest angle. Say I want to solve for angle B here. We know it's not going to be greater than 90, so I'm not going to run into multiple solutions because it's not the largest angle. So what we're going to do here is we're just going to do sine of 50.1, and again, if you could use the exact value instead of the rounded value, that's even better. Over 12 is equal to sine B all over 13. So in cases where we are trying to solve for more than one thing, I would do law of cosine once if I need to, if I can't find any other way. And then I would use law of sines once, so let's do that. So if I solve this thing out, and I'll do this kind of quickly because you've been doing a bunch of these. So we end up with B is equal to 56.2 degrees. Okay, that seems reasonable. Okay, so I've used law of cosines, I've used law of sines, and then I would just subtract these guys out of 180. Okay, so I've got 180 minus 56.2 minus 50.1, and I would end up with 73.7 degrees, all right, for that angle up there. And that makes sense. It's the biggest angle, but these sides are all very similar in size, so we aren't getting something huge as far as an angle. All right, so hopefully that's helpful. Hopefully you can see how we use law of cosines, whether we're looking for a side or an angle. And then also if I'm trying to solve for the entire triangle, what I'm going to do is I'm going to use law of cosine once, then use law of sines with the smallest, next smallest side, okay? That's the important piece there. And then do our subtracting out of 180. So hopefully this is helpful. But this wraps up our lesson on law of cosines.